Hey guys, so today we are going to go through some notes and hopefully you will get a better understanding of empirical formulas and how to do the worksheet entitled Empirical Formulas. Okay, so in this unit we're going to be covering empirical and molecular formulas, and I just want to kind of briefly run down on what those two things are. So a molecular formula is your actual formula, your true formula. So in the case of sugar, it is this. So C6H12O6. That is how you make a sugar molecule. But your empirical formula is your lowest ratio. Okay, so for example, this C6H12O6 can be like fractioned down into just CH2O. Okay, because the ratio stays the same, and it is your lowest ratio. Okay. So let's look at some examples and, kind of figure out how to calculate empirical formulas. So just for the sake of listing things, the first step that you're going to do when given a empirical formula problem is you are going to always convert what you are given to moles. Okay, and again, that's because you can't compare grams to grams like we're doing moles here, okay, without having to do like some wild those big long T-charts where you convert, no, just convert it to moles, makes it easier, okay? Then our next step is going to be, we're going to divide each element, the moles, by the smallest mole, okay? So we're going to convert everything to moles, then we're going to find the smallest mole, and we're going to divide everything else by that number, okay? You'll see what I mean here in a minute. Then we're going to take that ratio to make a formula, okay? Now, let's actually do some of these so you can see what this means, okay? And I'll keep referring back to this so that we can see how it actually applies, okay? Sorry for the jump cut, y'all. I recorded the problem wrong the first time. Okay, so our problem is going to be calculate the empirical formula of a compound containing 0.2636 grams of nickel and 0.0718 grams of oxygen, okay? So our first step that we're going to do is we're going to convert both of these values into moles, okay? So if we have nickel, we're going to take 0.2636 grams of nickel. Okay, and I know from looking at my periodic table that nickel has an atomic weight of 58.69 grams are in 1 mole. Okay, and that's going to give me my molar amount, and if we plug that real quick into our calculator, gives us 0.00449 blah 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 blah. Okay, so I know that that's a really big number, and I'm not really being very nice with my sig figs, and it's because here in a minute I'm going to round to the nearest whole number. Okay, so I'm just kind of leaving this guy long right now. Okay, so that is how many moles of nickel we have in this sample. Okay, and then we're going to do our oxygen, so 0.0718 grams of oxygen. I know that 1 mole of oxygen is 16 grams. So I'm going to plug that into my calculator, and I get 0.0044, honestly it's 9, okay, because if I rounded there, I'm going to round here, okay? So what I've just found out, that in this empirical formula, I have this many moles of nickel and this many moles of oxygen, okay? Or in this compound, rather. All right, so my next step is I'm going to take the smallest molar amount and divide everything by that. Now, in this case, they're the same. So when I do nickel, I'm going to take nickel's amount, and I'm going to divide that by nickel's amount. We'll say that nickel is the smallest. It doesn't really matter because they're both the same. So that is going to give us a ratio of 1. Okay. Now when we do oxygen, we're going to divide it also by nickel. And that's going to give us 1 there as well. Okay, so we're going to use these numbers that we just found to make our empirical formula. Okay, so what this means is that for every 1 nickel, I have 1 oxygen. And that is our empirical formula. Okay, so there are lots of different ways that these problems can be asked. In this case, it was literally just, we know we have this much and this much, find the formula, okay? But let's look at a little bit more challenging of one, okay? So we have a sample. The total mass is 7.843 grams, and I know that 4.151 grams of that is aluminum. If the rest of that sample is oxygen, find your empirical formula, okay? So this one's actually not hard. I lied when I said it was more challenging, okay? It's just a little bit more of simple math at the beginning. So I know that 4.151 grams of my sample are aluminum, okay? And I know the total mass of this sample. So it is really easy to figure out how much the oxygen is because you literally are just going to subtract. So our oxygen is, oh, that's why that's wrong. Okay, sorry, I was looking at my notes and I was like, I didn't get the same answer. It's because the math in my notes is wrong. Okay, so 3.692 grams is our oxygen mass, okay? So our first step is going to be, we need to convert these over to moles, okay? So I'm going to take my aluminum, and I know I have 4.151 grams of aluminum. I know that looking at the periodic table, 26.98 grams of aluminum is 1 mole. So I'm going to put that into my calculator. And that gives me 0.1539. Okay, and then I'm going to do the same thing with oxygen. Okay, so I know that I have 3.692 grams of oxygen. And looking at my table, I know that 16 grams is 1 mole. Okay, so I'm going to put that in my calculator. And that gives me 0.2308. 2308. Okay, so you can see in the last problem, these numbers were the same, so it was a 1-to-1 ratio. This time they're not. So we're going to have to figure out what that ratio is, okay? So step number 2 is going to be taking our smallest number and dividing both of these numbers by that smallest number. So in this case, our smallest number is going to be the aluminum value. So it's going to be 0.1539 divided by 0.1539, which is going to equal 1. Okay, and then down here, we're going to take 0.2308 and divide that by 0.1539. Okay, so 0.2308 divided by 0.1539, and that gives us 1.5. Okay, now we need to add something to our notes on that first page, and it is, we never round during stage 2. We never round a 0.3, a 0.5, or a 0.7. Okay, because those are in that awkward middle of the rounding area that just make it really hard to get a whole rounded thing. Okay, so like 0.3, it's going to be really like hard to justify rounding that up or down. 0.2 and 0.1, obviously you round those down. But in this case, we're never going to round 0.3, 0.5, or 0.7. So what that means we have to do is we have to find the whole number that this is closest to. All right, so in this case, we're just going to multiply this guy by 2 to give us 3, which is a whole number. Okay, now, since we did this multiplying by 2 here, we have to do it up here as well. So that is now our new ratio. This does not happen very often. You just need to be aware that, like, if this was 1.8 or 1.9, that's an easy round. But because it is 1.5, that is like dead smack in the center. And so we never round 0.3, 0.5, or 0.7. You always have to find the whole number that those guys are closest to. So our third and final step, let me move my camera so that we can see that one. Our third and final step is going to be to take our are numbers that we found here and here, and we're going to use that to make a formula. Okay, so what these numbers mean is that for every 2 aluminum, I have 3 oxygen. Okay, I wrote that really bad, I'm sorry. Okay, so in our formula, we're going to have 2 aluminums and 3 oxygens, and that is our formula. Okay, so the final type of problem that you're going to run into, cute, there's the bell, is going to look like this. Okay, so the question just says, find the empirical formula for, and then you just have a long list of percentages. Okay, so we don't actually have any weights. So like, how do you convert those to moles? We don't have any weights. Okay, well, if we have these as a percentage, that means that if I have 100% of a thing, 59.69% is going to be lead. So I'm just going to kind of cheat this a little bit, because I know that 100%, and this is how much I have, that means that if I have 100 grams, that means that I have 59.69 grams. Okay, so we are just going to convert those over into grams, pretending that our sample is 100%. Because, again, we're finding the ratios, so even if your end sample isn't 100 grams, like, your ratios will still hold, okay? So now I have my grams, and I'm just going to go on like normal. This one's a little longer because there's 4, but my first step is going to be converting all of those weights, or all of those masses, into moles. So I'm going to do PB, HONAS. So I've got 59.69 grams, and my periodic table says that 1 mole of lead is 207.20. That equals 0.288. I'm just going to use my already done notes because this one's long. I'm not going to actually calculate these out for y'all. I'm going to take my 0.2910 and 1.01 is 0.2881. My oxygen is 18.44 over 16, which is 1.153. And my arsenic, which is 2158. And the periodic table says 7492, so 0.2880. Okay, so here are my molar amounts. So I have 0.2881 moles of lead in this compound. Okay, so I'm going to find my smallest one, which in this case is the arsenic. And then I'm going to, step number 2, divide all of those other values by arsenic's value. So PB is going to be 0.2881 over 0.2880. That's going to be like 0.9 or 1.1. Let me just do it real quick. 0.2881 divided by 0.2880. Yeah, it's 1.000. That's 1. We round that to 1. That's easy. Okay, so that's 1. Hydrogen, I think, is going to be the same. Yeah, 0.2881 over 0.2880 is going to be 1. Oxygen is 1.153 over 0.2880. And that one is, let's see, 1.153 over 0.2880 is 4. Okay. And then arsenic is obviously going to be 1 because it's this 0.2880 divided by itself, which is going to be 1. Okay, so now step 3, we're going to take these values and use them to make our formula. So what this means is that I have 1 lead, 1 hydrogen, 4 oxygens, and 1 arsenic. That is the empirical formula for that equation. All right, cool cats. This should help you get through that worksheet. If you need anything else, please email me or Dr. Howard or Miss Watson and let us know. And I will see you guys in the next video. Bye.